Good morning, class.
Good morning, Miss.
And how are you doing this morning?
Fine, Miss.
Everybody's doing okay? Tanisha, you okay? Alright. Now, this morning, we're moving on to a slightly different topic. And I'm going to give you a little scenario, and you're going to try to figure out what is it this topic is all about. Then I'm going to give you the name of that topic. Right? Yes? Shazad? You're making a guess? Alright. Listen to this scenario. Imagine you're walking from the school gate, which is in front, 10 meters east, then 5 meters north to meet your friend. Right? So this is like Tyrone comes to school in the morning, he starts at the gate, and he walks and goes straight to the canteen. He's hungry. Right? Early morning, he's hungry. And he moves in different directions. He walks 10 meters east, and then he walks 5 meters north to get to Nikela. Right? Notice I'm giving you the distance as well as east and north, which is what? What do we call it? Starts with D. Direction. Good job. Now, if you wanted to show your total movement on paper, could you draw it with a single arrow, meaning from the gate to the canteen?
Yes.
What would we need to do? Yes, I don't hear. Yes, you can't just a straight line because you didn't move just a straight line. You move from the gate to the canteen and then move back to Nikela, right? In different directions. Yeah, well, we get measurement in it. Now, the two key words came out of that scenario. Both of them start with D. One was what? Tell me one, Stephen. Direction. Very good. Ada, tell me the other one. Destination. All right. Shazad, tell me the other one. It starts with D. We move from the gate to the canteen, and in between that's 10 meters. What do we call that? Very good, Mahendra. Distance. So we're dealing with direction and we're dealing with distance. Give yourself a clap for figuring that out. Good. Now, when we deal with direction and we deal with distance, we're looking at a topic called vectors. And if you look to the board, we have vectors and scalar quantities. There's a difference with the two. That is what we're looking at today. Right? Now, if I am to give you another example, Tyra, come with the ball. Either you come, the Kayla come. So the Kayla, you stand there, Aiden, you go there. Tyra, you go there. Now I am here, right? Michaela, come up. If I throw this ball to Michaela, I'm throwing it in a particular direction. And the distance from me to Michaela is different from me to Tyrone. Throw it back. So I throw it to Tyrone, I'm at a different angle, right? Whether it be north, south, east, west, whatever it is, it's at a different direction. Me throwing it to Ada now. Is the distance the same with Nikela and Tyrone?
No.
It's different. Is the direction the same? So you see, vectors are all around us. You do it every day, but you just don't realize it. It includes direction and it includes the distance. Here we go, Tyrone. You can have a seat. Get it, go like this. Good. So now I have a handout here for you that gives us example of vectors in everyday life as well as scalar quantities. And using this handout, we're going to discuss difference with the two. Right? So pass it around, everybody take one. Everybody take one. Alright, the two of you could share and give one to Shazad and Tyler. Good. Everybody can see in a handout now, right?
Yes.
Now look at that little box on top. It says scalar, which is size only, and vectors, which is size and direction. Now look on the screen. What is a vector? Somebody read the first point. One person.
A vector is a quantity that has both
Magnitude.
magnitude and direction.
Direction. Now magnitude is another word for distance. Right? And we already established that just now when we use a scenario with moving from the gate to the canteen and with the ball. So we know the vectors have the distance, or we could say the magnitude and the direction. What's your second point?
Always involves
About a specific direction. Now you remember the cardinal points. You remember this?
Yes.
Now,
Never eat soggy water.
yeah, that's an acronym for it, but we could say never eat sour watermelon. That is how I remember it.
You know what?
Never eat sour watermelon. That is how I remember the north, south, east, west. Right? So when we talk about direction, that is what we're talking about. Right? If it's going to be 50 meters to the east, 30 meters to the west, whatever it may be. Any questions so far?
Yes.
Shazad, you understand?
Yes.
Tyra?
Yes.
Good. Now what about scalar quantity? Somebody else read for me?
A scalar is a quantity that has magnitude only.
Magnitude only. The second point?
Does not involve direction.
It does not involve direction. So the scalar quantity is like you're saying you're moving 20 meters to the canteen. Right, Tyrone? You're not specifying which direction you're going. Not specifying, okay, I'm going north, I'm going west. You're just talking about the distance. Now, I have some examples there on the board of scalar quantities and vector quantities. Now, when you're driving a car, let me see how many of you know to drive. Look how fast the man is off.
Even put on game. How much I know for it, but
There's what, 5 of you know to drive, okay, you know to drive? Good. Well, then you know about speed. When you drive along the road, what's your speed that you usually drive, Tyrone?
me?
Yeah.
190.
190?
Oh, no, it does excite no 140 and 150.
On the road, on the country road?
Yeah.
Shazad, what about you? Mahendra, what about you? 150. Okay. Ada? 40. Alright, that is reasonable. That is good for the country road. Nikela, what about you? 50 to 80. Yes, Tyrone.
It was called the route.
I'm asking for country road.
I just said 150, 140.
Alright. Now, you notice that all 5 of you just told me the scalar quantity. You just told me your magnitude alone. You didn't tell me direction. So that is an example there of a scalar quantity. Your speed. You didn't tell me you're moving 150 north.
Oh.
You understand?
Yeah.
Good. You just told me the 150 came forward. Now, another example is mass. Right? The weight of that apple. We have volume, we have time. Now let's switch over to vector. We have weight, friction, and velocity. Now, if you look on your worksheet or on your handout rather, there are some other examples there of vector qualities, and it has a simple description.
force.
Good. So now that we went through some examples of vector and scalar quantities, I'm going to give you these little cards, this is a cutout with examples on them. Now what you're going to do for me, I'm going to give you a minute or so, and you're going to identify if it's vector or if it's scalar, right? Any questions? You can look back on the slide that's on the board, or you could use your handout. If you turn to the back, there's some other examples there. Right? You could turn over and you would see more examples there. For instance, it has scalar quantities and a list of them there. Distance, speed, time, mass, temperature. So we're going to start with Shazad just now, right? Shazad, let me hear you. Show us your picture and you tell me if it's a vector or a scalar quantity.
Scalar quantity.
How is it a scalar quantity?
Just because it's your walk.
It's just walking, right? Yeah. Mahendra?
This is a vector. The boy throwing the ball.
He's throwing the ball where? In a
Particular direction.
good boy. In a vector. How is it a vector?
Just moving to something.
Okay, good child. Daniela?
Scalar because of how fast it's moving, no direction.
Uh-huh. Very good. Sandra? Energy.
This one,
Turn to the back of your word. Look for the word energy and look on top. What is it? It is scalar, right? Tanisha, what about you? Time, so it is a, which one is it? Yes, how long something takes, but what is it? Scalar or vector? Scalar, very good. Give yourself a clap for completing that. Now, I want to show you one more thing before I give you this worksheet. Now, say for instance, we have to move 5 km east. How do we draw that on a diagram? Okay? We starting at A. This is our point A. And we have to move 5 km east. Where is east?
So,
Look, based on our cardinal points, where is east? We go in that direction to the A, right? Alright, so let me draw this.
by A to find B.
This direction. And we write it. We're moving 5 km east. Right? That is just one example. Now say for instance we had to move 3 km north. Right? We're moving 3 km north. We're starting at A. And north goes where? Where does north go? Up or down?
North can't say.
North going where?
Up.
Up. So we gotta go up. Here. Any questions? Any questions, class? You all understand?
Yes.
Alright. Now your worksheet has some quantities here, about 8 of them, and you're going to write whether it's scalar or vector. I'm going to give you this just now. The first question after the table says, give 2 examples of scalar quantities found in everyday life. Second one, give 2 examples of vector quantities found in everyday life. Remember we talked about it, right? You have those examples here. Just give any two, right? So, get it. If you have any questions while working, just raise your hands. Use your handout to guide you. Now that you've had enough time to go through your worksheet and complete those questions, you're just going to tell me your answer and how is it you get your answer. So we're going to start with Tyrone. The first one being 5 p.m. East. We talking about the table. So Tyrone, tell us your answer. You can stand please.
Alright. 5 km east is a vector quantity because it has direction which is east and direction which is 5. Which?
Distance.
Distance which is 5 on me.
Go try. Give him a clap. Second one, Shazad.
It does not have a direction.
Which one?
The second one.
You gotta read. Tell me the question. So number 2 is what?
Number 2 is 8 seconds.
Uh-huh.
And it does not have a direction.
So therefore, so what quantity?
A vector. Scalar.
Scalar. Good job. Give him a clap. Number 3 in the intro.
10 kg scalar. It talks about the heat.
Good. Give him a clap. Aiden.
25
Degrees.
Celsius scalar.
How is it scalar? How is it scalar?
Talking about the coolest?
I hear coldness. It talks about coldness. And does it give direction?
No, miss.
No. Well, this is why it is scalar. Stephen, give him a clap. Stephen, number 5.
A car moving 60 km because a nerd.
Hello. Shazad? Continue. Take your time.
Car movement.
A car moving 60 km
per hour.
per hour. Nerd is scalar.
Scalar? Anybody wants to help him? Mahendra, help him.
Number 5, a car moving 60 km per hour north is vector.
How is it vector?
Basically going north at the same speed as 60 kilometers. Yeah,
I'm looking for 2 words. Yes, Shazad.
You're going in a distance. You're going to a direction.
Distance and direction. That's the 2 words I'm looking for. Give yourself a clap. Number 6. Alicia?
The way the vocabulary is scalar because it has no sign.
It has no direction. Right? Very good. Give her a clap. Sandra?
The force pushing a door open scalar because it have no direction.
Good job. Michaela?
The time it takes to walk to school is scalar because it has no direction.
Good job. Give her a clap.
Yeah.
Good. So the next question on your worksheet is to give 2 examples of scalar quantities found in everyday life. Sandra, let me hear you. How far an object has moved? Can you be a bit more specific? Like, give me an example. How far it's from you. Alright, that can work. Give another example. You have another example? Good job. What about number 2? Vector quantities. Mahendra?
Yes, I walk to school. I have to go back to work.
You walk to school.
I have to go.
Alright, something wrong with the one. You get information, but the R in it you put. So you could put, you walk 5 km north from home to school. Right? Good. Yes, Ida?
I walk 5 meters.
You walk 5 meters east to school. Alright, good job. Give yourself a good. Now, I want us to look at one more thing, right? One more thing before we go today. Look at the bottom of your worksheet. There's a little box there.
Draw an arrow.
It says draw an arrow to represent this movement.
As soon as you walk 4 meters east and 3 meters north.
Alright, let's try this. So we go in, we're starting at A, and we have to move 4 meters east and 3 meters north.
So you can come.
Look on your worksheet at the bottom, there's a box there. A box in red. Can somebody please read what's in that box?
Draw an arrow to represent this movement. A student walks 4 meters east and 3 meters north.
Uh-huh. Continue.
Label the vector AB on your diagram.
Good. So we're dealing with A and B. So we start at the point A. And how far do we have to move? Tell me. Four what?
4 meter east.
4 meter east. So we go in 1. Uh-huh.
And 3 meter north.
Which means we go in where?
Up.
Up. Which leaves us somewhere there, and then we connect the 2 points. But when you use a rule, it's going to be a bit neat. But we can label this 4 meters east. And what do we write up there?
3 meters north.
Good job. Do you think you understand that?
Yes.
Yes, miss.
Good. Any questions? Any questions, class?
No, miss.
Alright. Now I just wanted to show you that we're going to look at that in a little bit more detail in the next class. Now to recap our lesson, let me see if you remember. We're going to look at vectors and scalar. Let me see if you remember. Think about everything that we did so far. And I want you to summarize what is it you learned. Think about it. Good. 2 persons. Any 2 brave persons. One stand and tell me what you remember about vectors, and the next person stand and tell me what you remember about scalar quantities. Yes, Shazad.
Vector is a size of something, distance, speed. That was distance, speed, and then
I'm looking for 2D word.
distance and destination. Direction.
Distance and direction. Good. Give them a clap. And what about scalar quantities? Yes, sir.
A scalar quantity does not include direction or
Or distance, or just does include one? Good job. Give her a clap. Now, do you have any questions for me before we go? Is there anything you don't understand?
I understand that.
Now, what you're going to do for me for homework, on the other side of your worksheet, there are some questions there that are related to what you did today. Right? So, you're going to do that for homework.
Okay, miss.